Thank you, Mr. Chairman. It's my honor this morning to present to you part of my work. Gabriel Ddamulira. Sorry to say I defended my PhD thesis, and I think I'll be graduating in August this year. From National Agriculture Research Institute. That's an institute in Uganda mandated to do crop research, and there are several programs there, but my area and program where I fall is horticulture and oil palm, where we are mandated to do research on horticulture crops in Uganda. This morning I'm going to present part of my work on screening for new sources of angular leaf spot in common bean. My presentation will align as in giving the importance of common bean, why do we need the beans, the constraints around growing beans in Uganda. I also give the objectives and justification as to why I did this work. I'll finalize with research findings and conclusion from the kind of work I did. Why beans? Beans are a common crop in Uganda and globally. It's an legume crop grown by smallholder farmers as in provision of food for these smallholder farmers because it's not grown so much by commercial farmers, but it's a good source of protein for smallholder farmers who cannot afford animal fat. The surplus grown is always sold to generate income for the farmers, as well as the leaves are consumed to provide iron and zinc for those farmers or poor malnourished farmers who cannot afford other micronutrient supplements. In addition, it's grown in intercrop with other cereal crops as a crop which can provide nitrogen in smallholder farming systems. The production trend of beans in Uganda. Beans are mostly grown by smallholder farmers, and on average you find that around 0.2 to 3 hectares cultivated by an average farmer, and that's the national production range for Uganda. This is for an acreage of 3 hectares. That's what for us we consider as a commercial farmer. So you really see that the crop is basically for smallholder farmers, not commercial farmers as in other countries. Though in other countries it's cultivated largely by commercial farmers. And in this kind of setup, you find that 65% of these smallholder farmers grow it in a mixed crop system. They intercrop it with other cereals like sorghum, maize, and other legumes like groundnuts. The 35%, those are the so-called commercial farmers in Ugandan context, whereby the acreage is slightly larger, and those are the ones who grow it as a sole crop. In terms of yield averagely is low compared to the regional production. You find that in the national average is around 0.5, that's per hectare. This is much lower compared to Sub-Saharan Africa, where the average yield is estimated at 0.77 tons per hectare. But since 2000, there has been an increase in acreage for beans from 0.67 to 1.1 million hectares for Uganda alone. But despite the increase in acreage, there has been observed decline in yield per hectare. and it's at a rate of 4.5 per year. This decline in yield has been attributed by a number of factors. One of these are the low soil fertility we have, being that the crop is grown by smallholder farmers. Farmers cultivate the land continuously because they don't have any other open area where they can cultivate. So with that continuous cultivation, there is loss of soil fertility, which contributes to the reduction in yield. There is also observed inadequate agronomic practices. You find in Uganda, farmers rarely use fertilizers, and the fertilizer user rate in Uganda is 1 kilogram per hectare, so which is very low compared to other areas elsewhere. Secondly, also inadequate practices. Farmers have not yet adapted to improved production practices. So this all contributes to the decline in yield we are observing. Thirdly, we also have a problem of seed. There is lack of quality seed. Farmers always depend on home-saved seed. So this home-saved seed is regenerated every other time. So you find that this also contributes to the reduction. But being that Uganda lies in the tropical areas, it's a haven of pests and diseases, and these are the worst when it comes to bean production. And in Uganda, there are several pests and diseases, and these range from right from the production up to harvest and even storage. Some of these are anthracnose, common bean viruses, angular leaf spot, bean weevils, brochids, so many, just a few to mention. These also are known to contribute to the reduction in yield. But among these diseases, we have angular leaf spot caused by Pseudoscopola glycola. This is considered as the second most biotic factor affecting bean production. And it's estimated to cause a yield loss of around 50% because in its advanced stages, it leads to defoliation of the leaves, affecting the photosynthetic system for the plant, hence contributing to reduction in yield. Further infection of this disease cause scars on the pods as well as the seeds. This affects the market value because it's grain seed with scars is not preferred in the market. As well as that secondary infection, or the scars carry the spores for the disease. So farmers recycle the seed, and in the end, that can be a secondary infection in the subsequent seasons when such kind of seed is planted. So there is reduction in quality of seed. The existing methods are not adequate enough to control this disease. That's why the disease has been continuously affecting the production as well as the yield. Some of the cheaper way of controlling this disease is use of crop rotation. But as I mentioned earlier, due to land shortage, these farmers cannot carry out crop rotation. Fungicides elsewhere have been found to be effective in controlling this disease, but unfortunately for our country, farmers are too poor to buy those fungicides. And on top of that, the fungicides are not environmentally friendly. So we are looking at cheaper methods of controlling disease using resistant varieties. So for this study, we looked at screening our land races to find out whether there are some sources of resistance. There are already existing sources of resistance developed from elsewhere, like CIAT has already had some of the resistant varieties, but these are not adapted to our country because they are not developed from there. So we cannot use them and optimize on the yield. Further still, in Uganda, bean preference by consumers depends on the seed size. most of the consumers prefer large seeded beans compared to the small seeded. So we also looked at the option of looking at the reaction of this disease vis-a-vis the seed size. How did we achieve this? We carried out the screening using 74 land races, including some of the 4 released varieties within the country, and the controls which are universally known for being resistant and those which are susceptible. For the screening, we used 4 isolates. 2 were externally provided from CIAT, the first 2 were, which is 116, 21, 39. Then the 2 were from Uganda, being that we are screening the materials from Uganda, and 1 was one of the most virulent isolate within the country. That's the 6163, and 1739. This is the most prevalent. By prevalence, I mean it's almost found in all bean producing areas in Uganda. The materials were screened in the screen house. They are planted in pots, and each isolate was treated as a separate experiment to avoid the cross-contaminations between the 2 as we are carrying out the experiment. And at trifoliate stage, the isolates were inoculated, the beans were inoculated with isolates, different isolates at different stages. Then disease scores were done using a scale of 1 to 9 adopted by CIAT. And these observations were taken at an interval of 3 days for 21 days. And it was, the observations were initiated at 6 days after inoculation. After scoring, area under disease progress curve was calculated. This was done using the midpoint rule method and adopting the equation seen there. And this was done to find out the reaction of each bean genotype we were evaluating. We started with a big mass, as I said, the 74. But in the preliminary screening, we screened, and all those which happened to be susceptible were discarded. Discarded in the way that we wanted to confirm. So for the second test, the second evaluation was to evaluate those which had happened to be resistant and moderately resistant in the first screening. So this is what we observed. For the first screening, area under disease progress curve was significant for all the land races for the 4 isolates used. For the commercial varieties, only area under disease progress curve was only significant for only 2 isolates. The other 2, there was no significant difference for that. So in terms of percentages, in the preliminary screening, 14% of the total material screened were resistant, 22% were moderately resistant, and the 54 were susceptible, and this is what we discarded. Then for the confirmatory test for the 40 land races which had happened to be resistant in the first screening, when we did a confirmatory test using the same procedures we had adapted in the first, only 1 land race, which is U297, happened to be resistant to the 4 isolates. Then U0074 and U351 and U9, these 3 were resistant to 3 isolates but susceptible to the most virulent isolate, which is 6163. Among the commercial varieties, all were susceptible except Nabe 12. This is a recently released variety. which was only resistant to only 2 isolates. Excuse me, this is a big table, but just explaining what I was saying, to summarize it, is those in blue, those are the ones which were resistant to 3 isolates, and the one in red, U297, is the only one landrace which was resistant to the 4 isolates. We confirmed it being resistant because it had the same reaction as but this red, but that's the positive, that's the universally known source of resistance for angular leaf spot in beans. So if you look at all the classes, all the reaction for all the 4 isolates, it had all resistant as our landrace, meaning that our landrace was at least confirmed resistant to the 4 isolates. Then we also confirmed that the isolates we used were variable because the source we used as a negative control, which is a local landrace, Kanyebwa, it was susceptible to all the 4 isolates. We went on to look at the effect of seed size, and for seed size, we followed the same procedure as the first, except that for the seed size, we had equal number of small seeded, large seeded, and medium seeded. These were planted in the screen house. After planting, they are inoculated with the 4 isolates I mentioned earlier. Then they were maintained in the screen house by covering them with polythene. This is done to create an humid environment to facilitate the infection of the pathogen. And then 6 days after, observations were made for symptom appearance, and then area under disease progress curve was calculated. For this, we observed that most of the large seeded beans for this kind of experiment were susceptible compared to the small seeded. In the small seeded category, majority were resistant. These results did not differ much from what earlier scientists had reported, like Paul Gates reported in 2008 that most of the small seeded beans are more resistant compared to the large seeded. But in the end, but the reaction was only significant for only 1 isolate, the CEAT isolate, which is 1,6. For the 3 other isolates, there was no significant difference in terms of reaction for small seeded or large seeded. But the problem we have is, despite the fact that the small seeded happen to be resistant, but as I mentioned earlier, in Uganda, the small seeded are not preferred. So a task remains how to integrate this resistance into the preferred material. These are just pictures of some of the few plants. Those you see with the clear leaves, those are the small seeded. Then some bit of infection for the medium seeded, and the large seeded were highly infected. From this, what conclusion do we draw? U297 was identified to be resistant to the 4 isolates. Then the other 3 were found to be resistant to only 3 races, but susceptible to the most virulent isolate. That's for the Ugandan side. And Nabe 13, which is a recently released variety, was at least moderate and resistant to the 2 isolates. The explanation, maybe I didn't mention it, is that over time, this pathogen tends to evolve. So the explanation as to why the rest of the varieties were susceptible is that they were released sometime back in the 80s. So over time, the resistance within such kind of varieties could have been broken, or even new strains could have evolved, which could make this the older varieties not resistant anymore. But you also realize that even the recent one is not so perfect, meaning that there should be continuous search for new sources of varieties if we are to sustain bean production in Uganda. Then the small seeded, these were more resistant to isolate 1,6, but we need to integrate this resistance into the most preferred. We recommend that this is not the final way to go, but U297, since it was tested under screenhouse condition, should be taken into the field to validate its resistance under natural conditions. I would like to acknowledge my funders, Forum, CIAT, Boraglip, Carnage, and my institute, and also Makerere, for enabling me to attend this conference. Thank you for your attention.
Thank you, Dr. Ddamulira. I think the time is up, but we can accommodate maybe a question or two. Yes.
I was curious as to why the small seeded are not preferred. Is it because of their it's not a big enough plant, or is the yield not good for a small seeded?
Okay. The small seeded, actually, in terms of consumption, they are the best. But when it comes to sell, because the bigger ones tend to accumulate bigger mass and weight, they prefer the big seeded. So if you are going commercial, it's the big seeded. If it's just home consumption, it's the small seeded. It's the other, vice versa.
So the small actually tastes better?
It tastes better.
But it's not because the farmers are going for weight because of the value, they get more money because of the weight?
Definitely.
Oh, so the quality isn't as important.
Yeah.
One more question. Yes, Amy? Okay, comments?
Can we know the isolate, the four isolates you extracted from the inoculated?
I beg your pardon?
I mean the isolate you inoculated. Just only one strain you inoculated? Only one strain of your organism?
No, these were purified isolates because the initial part was to do the isolation and characterization, which is another completely study. So it's out of that study that these four, what I called the four, were pure isolates. So, and each was treated differently, as I said, to avoid the cross-contamination. So there was no mixing the strains together then apply. Each was treated differently as a single strain. Yeah.
Do you identify them?
Yeah, they are fully identified and characterized. Yeah.
Thank you, colleagues. Thank you. We can go to the next presenter.